This video is an extension of lesson 8.3 and it's entitled Define and Use Fractional Exponents. You should be on page 509. In lesson 2.7 you learned to write the square root of a number using a radical sign. So let's recall or review that. You know, a radical sign would be that symbol. So when we see this, for example, this is saying the square root of 9, and that equals 3. This is asking what number times itself would give you 9. In other words, 3 squared equals 9. 3 is the number I'd have to square to get 9. You can also write a square root of a number using exponents. Okay? The square root of a is equal to a to the 1/2 power. So in other words, the square root of 9 would equal 9 to the 1/2 power. Why don't you pause the video real quick and plug in 9 to the 0.5 power on your calculator, and you'll see you get 3. Now, when you have a base to a power that's fractional, here's what the fraction represents. The number in the numerator we consider a power. So this would be like a to the 1st power, but the number in the denominator is the root. So this is saying take a to the 1st power and then take the square root, or you could do the square root first and then apply the 1st power. Let's look at that with 9. Okay? 9 to the 1/2 power. Let's analyze that. So this means the 1st power of 9. Well, 9 to the 1st power is 9, and then this says take the square root. Well, what's the square root of 9? And it would equal 3. 9 to the 1/2 power equals 3. Now, the order of a fractional power doesn't matter. I could apply the square root first and then the power. Let's try that. The square root of 9 is 3, and 3 to the 1st power would get you 3. So you notice it doesn't matter if I apply the power first and the square root second, or vice versa. I ought to be getting 3 either way. Let's actually look at some examples. You see the answers here, but let's explain why we get the answers we do. Okay? 16 to the 1/2 power. So when I look at that on paper, that means I can take, let me highlight this, I can do the square root of 16, which equals 4, and then I have to do the 1st power of 4, which equals 4. That's why we're getting 4. Okay, let's look at this one. 25 to the negative 1/2 power. Well, the negative means move 25 to the denominator and 1/2 power it there. Okay, let's do the root first. The square root of 25 is 5, and then I still have the 1st power. 5 to the 1st power is 5. You're getting 1/5 out of that. Let's go to this. We have 9 to the 5/2 power. Now, the way the book explains it, I'm going to do something a little different. 9 to the 5/2 power. I can do the root first. The square root of 9 is 3, but I still have the 5th power. 3 to the 5th power means 3 times 3 times 3 times 3 times 3, and that's 243, which is what the book has. Okay? Same thing here. 4 to the negative 3/2 power. The negative means move 4 to the denominator and 3/2 power it there. Now, the square root of 4 is 2, but I still have the 3rd power. 2 to the 3rd power is 8. I get 1/8. Okay? So those would be some examples of working with square roots. Why don't you try these 4, no calculator? I'll put NC for no calculator. Go ahead, pause the video, and try those 4. Okay, we're back. So this is saying the square root of 49 is 7, and then I want a 1st power of 7. You ought to get 7 out of that. this one, the negative exponent means move 36 to the denominator and half power it down there. Well, the square root of 36 is 6, and then the first power of 6 is 6. You ought to be getting 1/6 for this. Here, 25 to the 3/2 power. The square root of 25 is 5, but then I got a third power that. 5 times 5 times 5, that's 125. And then here, the negative exponent means move 4 to the denominator and 7 seconds power there. The square root of 4 is 2, so I have to do 1 over the 2 to the 7th power. That means I have to do 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, times 2, which is 64, times 2. That's 128 in the denominator. I ought to get 1 over 128. You will definitely have a few no calculator questions on a quiz over this material. I wouldn't make all the problems no calculator, but I want to know basic ones like this. You at least know what the exponent, how to apply a fractional exponent, and the only way I can know is take away the calculator, or else it's just plug it in. It doesn't show me you know anything. Now, with that understood, I think it's time to look at what a cube root is. If b cubed equals a, then b is the cube root of a. Now think about it. A square root, let's just talk real quick. A square root like this means what number times itself would give you 9, and we've already talked about that. That's 3. Okay? But let's think about the cube root of a number. This definition is saying I am looking for the number that I can multiply together 3 times, and it would give me 8. Well, the cube root of 8 is 2, because think about it. Isn't 2 times 2 times 2 8? Cube root means I need the same factor 3 times, and it has to multiply out to 8. Okay? You notice a cube root has a little 3 outside the radical, where here, whenever you see just a radical, that automatically means second root. We normally don't write the 2 like I did there. If you don't see a number, it means square root. So let's practice evaluating some expressions involving cube roots. Like here, 27 to the 1/3 power. That means I want to take the third root of 27. So what times itself is 27? Well, 3 times 3 times 3 is 27. So I'm getting 3. The cube root of 27 is 3, and I have to first power that. 3 to the first power is 3. Or here, 8 to the negative 1/3 power means move 8 to the denominator and 1/3 power it there. The cube root of 8, what number times itself times itself times itself gives you 8? Well, 2 times 2 times 2 is 8, so the cube root of 8 is 2, and now I have to first power the 2. I get a half out of that. Okay, or here, 64 to the 4/3 power. The cube root of 64 is 4. 4 times 4 times 4 is 64. And then I have to fourth power the 64. Well, 4 times 4 times 4 times 4 would be 256, which matches here. And then here, I need 125 to the negative 2/3 power. That means move the 125 to the denominator and 2/3 power it there. The cube root of 125 is 5, because 5 times 5 times 5 is 125. And now don't forget, I have to square that. That's 1 over 25, which matches what we have here. Okay? Now, when we do these problems today, the properties of exponents that you've already learned, that would be from lessons 8.1, which were the multiplication. I'll just put a time symbol. These were the multiplication property of exponents. And the properties from 8.2, which is the division property of exponents, and the properties from 8.3, which applied to negative exponents. All of those properties apply when you work with fractional exponents. So here would be an example. a problem like this, do you notice how we're multiplying and you have the same base? You should be able to add the exponents. So 12 to the negative half power times 12 to the 5 halves power, we should be able to add those exponents. Well, negative 1 half, let me write this down here, negative half plus 5 halves is 4 halves, and isn't 4 over 2, 2? This is just 12 to the second power, that's 144. You notice the rules of adding our exponents when we're multiplying with the same base, it's still applied even though we had a fractional exponent. Here, same thing. This is first power. So I can multiply, if I'm multiplying with the same base, I can add my exponents. So 6 to the 4/3 power times 6 to the first power would be the same as 6 to the 4/3 power plus, this would be 3/3 power, that's 1. That's why they're getting 7/3 power in the numerator, and we have 6 to the 1/3 power in the denominator. Well, if I'm dividing with the same base, I can subtract my exponents. 7/3 minus 1/3 equals 6/3 power, and 6 over 3 is 2. That's why we get second power. 6 to the second power is 36. So, again, the properties of exponents we've already learned we can use today, even though we have fractional exponents. I'm going to pause the video here. There's a book assignment and a worksheet assignment to do. Make sure you attempt those problems on each. If you have questions, make sure you ask in class.